Hello, my name is Russell Boudry, Router Product Manager here at MultiCam. Today we're going to be doing some thread milling. Now, thread milling is an application that allows you to create threads of any size from 832 on up. Now, you see this a lot in signage. Maybe you're doing standoffs in the back of acrylic or some aluminum. So this is an application that you're not limited to just a drill and tap spindle. You can do it on an automatic tool changing spindle or even a cullet spindle. This could really expand your capabilities at your shop.
The process of thread milling starts with what size hole you need to thread. So in this case, I wanted to do a 1/4-20. The tool I picked from this vendor, the website they had provided me all of the exacting details about the diameter of the thread mill itself, the depth that I could maximum go with this threading, and other important data. It also had a portion on there where it showed me a simple chart that if I started with a 200 thousandths diameter hole or a number 7 drill, I could have 75% engagement. This is all extremely helpful as we move into the process of putting this data into a CAD CAM. At MultiCam, we often offer En-route or AlphaCam as a CAD CAM solution, and both of these programs can do it, but they do approach it differently. En-route approaches it from a parametric macro, and you come in and you put in all of this information about where you want it in X and Y, the diameter of the thread, the pitch, which is simply 1 divided by 20, and the depth of the threads that you want to go, and all this information. And when you hit apply, it actually creates a vector of either a hole that can be that you can utilize for a bolt head or an internal hole. And so then you actually come in here and you can actually do a follow path, tool path with that tool. I found that AlphaCam was probably a little bit more user-friendly and does put out better code. En-route output a series of G01s, where AlphaCam actually output an actual spiral GO2 interpolation of this code. I also found that the thread milling process was easier because I was able to bring that exacting tool in with the DXF, sign the tool, answer these questions, and speeds and feeds, and before you know it, you're done. So I found this to be a lot more user-friendly than dealing with the vector. But once again, both can do it.
So our first tool is going to come in and it's going to create the hole for it to be threaded. So this is going to be a 200 thousandths hole for a 1/4-20. This will end up allowing us to have about a 70% thread engagement, which is pretty significant. We're now going to go back and pick up a thread mill, and there's different styles of thread mills. This particular one has got a flare in. There's other types where it actually looks like a tap end mill combo. There's different advantages. Both require this helical motion. You can see how it's literally going in and out, and when it's done, it's going to come back into the center and lift out. All right, so that is our hole. I'm just going to blow away any debris here. All right. All right, 1/2 inch 1/4-20 tapped hole.